Okay, we're going to move on to the next set of examples. So directions here ask us to simplify the expression, and then we're asked to assume all variables are positive. And lastly, you're told that your answer should only contain positive exponents. Okay, so in order to simplify things completely, we have to have positive exponents in our result. Okay, so for number one, we have the quantity x to the fourth power times y to the eighth power, which we're raising to the 3/4 power. Okay, so we have like a product raised to a power. So I'm going to apply the exponent to each of those individual factors, okay, which is like saying x to the fourth power to the 3/4 power times y to the eighth power to the 3/4 power. So what we have in both instances is we have a power raised to a power. So we're going to multiply the exponents for each one. So when I multiply 4 times 3/4, that resulting exponent is going to be 3. So that's going to be x cubed. And then we have y to the eighth power raised to the 3/4 power. Again, a power raised to a power, we're going to multiply the exponents. So 8 times 3/4 is going to wind up becoming 6. So that's going to become y raised to the 6th power. Okay, and we have all positive exponents there, so we are good. All right. With the rest of them, like there are different ways that you can work through these problems. You don't have to follow like the same order in which I do them. Okay, so for number 2, we have a squared times b cubed times 2 times a raised to the negative third power times b raised to the fourth power over a to the fourth power b to the negative 1 power quantity squared. Okay, so I'm going to go through and simplify the numerator and denominator first. All right, so I'm going to take that first factor, that numeric factor 2, and pull it out front. And then next, I'm going to multiply the factors of a. So we have a squared times a to the negative third power. So when I multiply two exponents that share the same base, we're going to add the powers. Okay, so that's going to make a to the 2 plus negative 3 power, which is a to the negative 1 power. And then I'm going to do the same thing for the factors of b. So we have b cubed times b to the 4th power. Again, if I'm multiplying two exponents that share the same base, I'm going to add those powers. So that's going to make b to the 3 plus 4 power, which is b to the 7th power. Okay, on bottom, we have a to the 4th power times b to the negative 1 power, which we are squaring. So just like we did in the previous example, I'm going to apply that exponent to each of the factors, which is going to give me a power raised to a power, which means I'm going to multiply the exponents together. Okay, so the power for a is going to be 4 times 2, which is 8. And the power for b is going to be negative 1 times 2, which is negative 2. Okay, I just want to go through and simplify this now. So we have that numeric factor of 2. Then I'm taking a to the negative 1 power divided by a to the 8th power, which if I'm dividing two exponents that share the same base, I subtract the power. So that's negative 1 minus 8. And then for b, again, I'm taking b to the 7th divided by b to the negative 2 power. If I'm dividing two exponents that share the same base, I'm going to subtract the power. So that's 7 minus negative 2, which is going to make 2 times a to the negative 9 power times b raised to the positive 9 power. And then the last thing I have to do is I need my exponents to be positive. So the fact that we have a raised to the negative 9 power, I can write that as 1 over a to the 9th power, which is going to put a to the 9th power into my denominator. And then the leftover factors we have in the numerator are going to be 2 times b raised to the 9th power. All right, so that is that expression simplified completely. Okay, I want to see you guys give numbers 3 and 4 a try. So go ahead and get those copied. Number 3 is 3x to the negative 2 power times y cubed, quantity squared, times 2x cubed y to the 4th power, that quantity raised to the negative 1 power, divided by x cubed y to the negative 2 power raised to the negative 2 power. And then for 4, you have the quantity u squared v to the negative 3 power times u to the 4th v squared, and then you're raising that result to the negative 1 power. Okay, so give both of those a try. Go ahead and pause the video when you're done. I'll work through the solutions to both. Okay, so let's take a look at 3. So the first thing I'm going to do for number 3 is I'm going to apply the exponents to each of those sets of factors. Okay, so when I apply the exponent of 2 to all 3 of the factors in that first product, we get 3 squared, which is 9. X to the negative 2 power squared. Again, power raised to a power, we multiply the exponent, so that's x to the negative 4th power. And then y cubed squared, we're going to multiply the exponent, which gives us y to the 6th power. Okay, then we're going to apply the exponent of negative 1 to all of those factors. Okay, so we have 2 to the negative 1 power, which I'm going to leave alone. X cubed to the negative 1 power. When I multiply those exponents, we get x to the negative 3 power. And then y to the 4th to the negative 1 power is going to make y to the negative 4th power. All over, when I apply the exponent of negative 2 to both factors on bottom, we get x cubed to the negative 2 power, which is going to make x to the negative 6 power. And then y to the negative 2 power raised to the negative 2 power. When I multiply the exponents there, we get y to the 4th. And then I'm going to simplify the numerator first, and then we'll look at the quotient at the end. Okay, so we have 9 times 2 to the negative 1 power. So 2 to the negative 1 power is 1/2. So 9 times 1/2 is 9/2. Then we have x to the negative 4 power times x to the negative 3rd power. So if we're multiplying two exponents that share the same base, we add the power. So negative 4 plus negative 3 is x to the negative 7 power. Lastly, we have y to the 6th power times y to the negative 4th power. So when I add the exponents there, that gives me y squared. And then on bottom, we have x to the negative 6th power times y to the 4th power. Okay, so we have 9/2. X to the negative 7 divided by x to the negative 6. When I divide two exponents that share the same base, we subtract the powers. So that's going to be x to the negative 7 minus negative 6. And then we do the same thing for y. So y squared over y to the 4th is y to the 2 minus 4 power, which is going to make 9/2. The exponent for x becomes negative 1. The exponent for y becomes negative 2. Okay, so I want to write this as a fraction. So the only thing we have left on top is 9. Then we're going to have a factor of 2 in the denominator. X to the negative 1 power is like 1 over x. So that's going to add a factor of x into the denominator. And y to the negative 2 power is 1 over y squared, which is going to add a factor of y squared in the denominator as well. Okay, so that right there is that expression simplified completely. Okay, let's do the same thing for number 4. So for number 4, I'm going to simplify what we have in the parentheses first. So when I multiply u squared times u to the 4th, When I multiply two exponents that share the same base, I'm going to add the power. So that's going to make u to the 2 plus 4, which is u to the 6 power. And then when we multiply v to the negative third times v squared, again, when I multiply two exponents that share the same base, I add the powers. Negative 3 plus 2 is v to the negative 1 power, which we're raising that result to the negative 1 power. So we have a product raised to a power. I'm going to apply the exponent to each of the factors. So that's going to make u to the 6 power to the negative 1 power, which I'm going to multiply the exponents there. So that's u to the negative 6 power. And then v to the negative 1 power raised to the negative 1 power. When I multiply the exponents there, we get v to the first power. And then the last thing I have to do is make sure the exponents are positive. So u to the negative 6 is going to put a factor of u to the 6 power in my denominator, and we have that factor of v in the numerator. Okay, so that is that expression simplified completely. All right, last set of examples to finish off the first part of this lesson. Okay, so directions here say to write the expression in the following form. So for number 1, we have the quantity, the fourth root of 2m, which we're raising to the 9th power. And we want to write that as an exponential. So if I want to write that as an exponential, we're taking the quantity 2m. The index of our radical is going to become the denominator of the exponent. So that's going to make the denominator of the exponent 4. And then what we're raising the power to is going to become the numerator of the exponent. Okay, so that's going to become the quantity 2m raised to the 9 over 4 power. Okay, for number 2, we have 1 over the fourth root of 3x, which we're raising to the 3rd power. Okay, so let's take a look at the radical first. So the quantity that's underneath the radical is 3x. 4 is the index of our radical. So that's going to become the denominator of the exponent. 3 is the power. And because that entire quantity is in the denominator, that's going to make that exponent become negative. Okay, so that radical expression with a rational exponent is going to become 3x to the negative 3/4 power. Okay. Last one we're going to work through in the opposite order. So this time we're given a rational exponent that we want to write in the form of a radical. Okay, so when we look at this, the only thing that the exponent is applying to is that factor of m. So 7 is completely separate from that factor of m. So if we want to take m to the 2/3 power, the denominator becomes the index of our radical, and then our numerator becomes the power that we're raising m to. So we can write that as like 7 times the cube root of m squared, or if you want to write it like this instead, 7 times the cube root of m, quantity squared, that's fine as well, okay? Either of those two interpretations are acceptable. Okay, so we're going to work through some additional examples with this in class on Wednesday. Make sure you guys have the homework that I assigned for the first part of this lesson done by the time you come to class on Wednesday. Okay, so I hope you guys are studying hard and do well on your quiz tomorrow, and we'll see you for a formal lesson in class on Wednesday. So hope you guys have a great weekend. Take care.